Alright, so we're going to start chapter 3, section 3 with long division. This is a pretty long section, but I'm going to do it in parts, right? So for today, I'm just doing long division, right? Not the kind of long division that you learn in elementary school, right? We're going to do it with polynomials. Alright, so I'm not going to spend too much time on the slide. I'm actually not even going to read the steps to this. I mean, these are the steps if you need a quick summary of what to do, right? If you're doing some problems and you need to quickly refer to, okay, what's the next step? You can refer back to this, right? It's just a summary of what all we're going to be doing, right? But the easiest way to do it, I think, is to just practice it, right? This will get easier over time, and if you haven't seen it before, it's going to look super weird, right? But it does get easier, right? It's the same process every single time. So before I jump into any of these examples, I'm going to quickly go over what we did in elementary school with long division, right? So let's say I had something like 691 divided by 5. Right now, a lot of us probably can't do that in our head super quickly. So what you do is long division, right? So just some quick vocab, right? So kind of to refresh your memories from elementary school, right? We haven't used these words in forever, but we'll use them here, right? So this number up top is called the dividend. All right, and this number down here, right? The number that's the, I guess, amount of groups that we're trying to fit the dividend into. We're trying to fit this dividend into 5 groups called the divisor. Right, so again, way back elementary school. Right, now when you go to do long division, you set it up something like this. You have your divisor on the outside and your dividend on the inside of this little box. All right, now you go digit by digit, right? The first digit is the 6. And so really what you're doing is you're saying, how many times does this 5 go into 6? All right, and it's going to be 1 time, and I'm going to put that right over the 6. All right, and then 1 times 5 is going to get you 5, and then you subtract. Right? You subtract and you end up with 1. You bring down this 9, the next digit, right? And then you repeat the process, right? So how many times does 5 go into 19? Well, think about it, and it goes into 19 3 times, right? And then what's after this? Well, you do 3 times 5 is going to get you 15. Subtract, and then you end up with a 4. Bring down the next digit, right? 41, right? So how many times does 5 go into 41? It goes into 41 8 times. And then 8 times 5 is going to get you 40. You're subtracting, right? You end up with a 1. Now, really, you would keep going. This is going to get you a terminating decimal, right? So if you keep going and you do your decimals, it should get you like 138.2, right? But with polynomials, we can't really do decimals. So for now, at least with this number, right, we usually just write the remainder sticking out some way. So remainder 1 or something like that. We're not going to write it like that with polynomials, but just so that you guys are aware, this remainder is kind of separate from our whole number answer that we got from dividing 691 with 5, right? We had a little bit of extra, right, that didn't quite perfectly fit into the 5 groups, right? And we'll see how to handle those as we come across it. But I want to start off with an example, something pretty simple, right? Fairly simple, right? I mean, again, if you haven't seen it before, it's going to look completely new and strange, right? But again, as you keep practicing it, it's going to get easier. So let's start by setting it up the same way, right? We know this number up top is our dividend, and our number on the bottom is our divisor, right? So let's set it up. We have our divisor on the outside, our dividend on the inside, x squared minus x minus 2. And what we're trying to do here is we're trying to look and see what do we need to multiply this x plus 1 by to get an x squared. Right, so you're kind of trying to think to yourself, okay, how many times does x plus 1 go into x squared? Right, that's how you think about it with numbers, but you kind of need to change the way that you think about it, right? Because now we're trying to think, what can we multiply x plus 1 by to get an x squared? Right? Think about it, and it's actually going to get you an x. I'm going to write the x over our x term. And what you're doing next is you do x times x plus 1, and that's going to go right underneath this x squared minus x, right? So we get an x squared plus x, right? Because that's what we get when we do x, this x right here, times this x plus 1, right? We get an x squared plus x. Might seem kind of strange, but look at what we did with our numbers, right? We got, let's say, okay, this 15 right here. We got this 15 from doing 3 times 5, and that got us 15, right? And then we subtract, right? And that's how we got this 4 right here, right? We do something pretty similar here, right? So we do x squared minus x, and then we do minus this entire expression right here. So minus x squared plus x. And that's going to change the sign of everything on the inside of the parentheses, right? And what should happen next, if you picked the correct factor up here, right? X squared and minus x squared are going to cancel out. And so you're left with a negative x minus x, and that's going to get you a negative 2x, right? When it was numbers, we would bring down our next digit. With polynomials, we're bringing down our next term. Our next term is a negative 2, so I'm going to bring down a minus 2. And you're going to repeat the process. So you're trying to see what can I multiply x plus 1 by to get a negative 2x, right? You don't really worry about this next term right here, this minus 2. We're trying to cancel out term by term, right? So let's first focus on what can we multiply x plus 1 by to get rid of a minus 2x, right? And think about it, and it's going to be a minus 2. Right, so meaning if I multiply this minus 2 with an x plus 1, right, distribute negative 2 to x plus 1, and you get negative 2x minus 2, right? And then after this, you would subtract, right? Subtracting, you would change the sign of everything, right? And so what happens now is we have a negative 2x plus 2x, that goes away, and we have a negative 2 plus 2, that also goes away. So we have a remainder of 0, right? So meaning that x plus 1 is a factor of x squared minus x minus 2, right? So this is going to equal, when you divide, x minus 2, right? So that's the process for long division. Again, if you haven't seen it before, which many of you haven't, it is a little strange, but the more you do it, it gets way easier. All right, so let's look at this next one right here. Right, so we have the same dividend as the previous problem, but we have a different divisor. We have an x plus 3. Right, so let's see how this changes things. Right, so let's set it up the same way that we would before. Right, divisor on the outside, so an x plus 3, x squared minus x minus 2, our dividend on the inside. And then again, let's go term by term and let's see. So first, what you're asking is, what do you need to multiply x plus 3 by to get an x squared? All right, and it should be an x, right? X times x plus 3 gets you an x squared somewhere in your expression, right? So we get an x squared, and then 3 times x is going to get you a 3x. 3x, right? So this x is going to distribute to each of these terms, right, is essentially what we're doing, right? And then when you go to subtract, right, so subtracting just changes the sign of everything. So I'm going to skip the parentheses, and I'm just going to jump right into switching the signs, right? We know that after we subtract, the signs are going to switch, all right? And then what should happen each and every single time is the term, this leading term right here, this x squared, should cancel out, right? X squared minus x goes away. Negative x minus 3x is going to get you a negative 4x. All right, and then bring down the next term, negative 2. And then we repeat the process. We need to ask, what can we multiply x plus 3 by? All right, so we want to multiply this by something to get a negative 4x, right? Somewhere in there. Right, and it's going to be a negative 4x, or a negative 4. Right, so if we distribute a negative 4 to each of our terms, right, we're going to get a negative 4x minus 12. All right, so I just distributed that negative 4 to our divisor. All right, and now subtracting this whole thing is going to switch the sign of everything. And what should happen is negative 4x plus 4x is going to cancel out. And so we get negative 2 plus 12 is a positive 10, right? I have no more terms to drop, meaning we have a remainder, right? So this 10 right here, this is a remainder. Now in polynomial long division, our remainders are going to be written as follows, right? So we're going to write plus our remainder over our dividend. Our divisor. So in sum, our answer is going to be this whole thing right here, this x minus 4 plus 10 over x plus 3. This whole thing is your answer, right? This x minus 4 portion, this was our quotient, right? This 10 right here, this is our remainder. And this x plus 3 right here is your divisor. All right. So hopefully it makes a little bit more sense after that. If not, I'm going to try a couple more examples today. All right, so let's set it up the same way, right? This is another division problem, right? So we're going to have our divisor on the outside and our dividend on the inside of a box, right? It's going to be a 5x cubed minus 6x squared minus 28x minus 2. All right, so we're going to do the same process that we did in the last two problems, right? So we're going to go term by term, right? Going from left to right, looking at that 5x cubed. Ask yourself, what do you need to multiply x plus 2 by to get a 5x cubed? Right, and it's going to be a 5x squared. Right, I'm going to line that up with my x squared term. Now, if you distribute 5x squared to this x plus 2, right, distributing it to both of these terms is going to get you a 5x cubed, which is what we wanted, right, plus a 10x squared. When you're doing these, don't concern yourself with what's going to happen afterwards. So don't worry about that plus 2. If it's easier for you, just don't even worry about it. Right? What you're really looking for is what can you multiply this x by to get a 5x cubed, and then the rest will follow, right? The rest is just going to be the same process that we've been doing, right? If you get something that doesn't completely cancel out, that's fine, right? Because we're going to account for that in the next step, right? So don't even worry about that plus 2 afterwards, right? Let's focus on the x, right? Now when you go to subtract this, right, just change the sign of everything. And what should happen is the 5x cubed minus 5x cubed is going to cancel out. We get 6x squared minus 10x squared is going to get us a negative 16x squared. Bring down your next term. It's going to be a negative 28x. All right. So this is what I mean when I say don't concern yourself with what happens afterwards. Don't even concern yourself with this 28x that we just dropped in terms of finding what to put up here. Right? And finding this term right here, you don't need to concern yourself with anything afterwards. You're just trying to see what can you multiply x by to get a negative 16x squared, right? And it's going to be a negative 16x. The rest will follow, right? So if that's confusing, right, if the extra terms make it a little bit confusing, right, just go one at a time. Look at the first term because that's what you're trying to cancel out, right? So negative 16x times x plus 2, right, so we're going to distribute it to everything here, is going to be a negative 16x squared, right, minus 32x, right? And now we can introduce our other terms again that we kind of just x'd out, right? So we're going to introduce that again, right? That's going to be a plus 2. This is going to be a minus 28x. Right, so introducing those terms again, just because now we know what to do with them, right? Now we change the sign of everything that we just found, and that's going to cancel out the negative 16x squared. And negative 28x plus 32x is going to get us a 4x. Drop your next term, and you're going to do the same process, right? So again, just look at the x term, right? The first term, if that's what helps you make better sense of it, right? So Now we're trying to see what can you multiply x plus 2 by to get a 4x, right? So x times 4 is going to get you a 4x, right? So I'm going to multiply by 4. When you distribute 4 to x plus 2, that's going to get you a 4x plus 8, right? And then now we subtract, right? So change all the signs. This has to cancel out the 4x, and then we have a negative 2 minus 8 is going to get you a negative 10. All right, and there's no other terms that we can drop, so we're going to write it as a remainder. And our remainders we write as plus our remainder over a divisor. All right, so then this right here is your answer, your final answer. So again, maybe is a little bit of a tedious process, right? But it's the same process every single time. All right, so hopefully as you do these examples, it gets a little bit easier. And we're going to try another one, a little bit of a different example in the next slide. All right, so this one's a little bit different from some of the other ones that we've done. Before I do it, though, I'm just going to start with a little discussion, a little example of, I don't know, something that we maybe are a little bit more familiar with, right? So we know that quadratics in standard form, right? So all of these that we've been doing so far are polynomials in standard form. And by standard form, we just mean that the exponents are in decreasing order, right? So ax squared plus bx plus c, for example, is a quadratic in standard form, right? So something like 3x squared minus 5x plus 6, right? That's something in standard form, right? But something that's also in standard form is something like negative 4x squared plus 3. Right, this is also in standard form because our exponents are in decreasing order, right? We have our x squared first and we have our constant second, right? So now in standard form, we should be able to label an a, b, and c. In this case, our a is going to be whatever's in front of our x squared. Our c is going to be our constant, but what is our b value going to be, right? If you don't see one, then it's going to be 0, right? Because really, there's kind of a little invisible x here, right? So we have a 0x. That's kind of, we're writing it in as a kind of placeholder for just to have a b term, right? But really, just writing this, negative 4x squared plus 3 is perfectly fine. In this case, with long division, we're going to want to have a space for any, we're going to want a placeholder for any missing variables. So something like x cubed minus 1, for example, right? It is in standard form, right? We see our exponent term first and our constant second, right? But we want spaces for any missing variables, right? So we have an x cubed, right? The next smallest exponent after an x cubed is an x squared, right? So I'm just going to write a plus 0x squared just to be some sort of placeholder, right? And I'm going to do the same thing for the term after that, right? After 2x's is 1x. So I'm going to write plus 0x, and then that minus 1 that we had originally is going to go back, right? And then on the bottom, we just have our x plus 1, right? So this actually makes long division a little bit easier, and you're going to see why. I will say for a long division, you might be able to get away with not doing this, but for when I teach you guys synthetic division, if you don't put the missing zeros, you get the answer completely wrong, right? So just get into the habit of doing it each and every single time. All right, so now let's set it up as we've done before. So we have an x plus 1 on the outside, and x cubed plus 0x squared, right? So with all of our placeholders, right? All this on the inside. And now let's see, what can we multiply x plus 1 by to get an x cubed, right? And it's going to be an x squared. So I'm going to line it up with my x squared term. X squared times x plus 1 is going to get us an x cubed plus x squared. All right, so just distribute that x squared term to x plus 1. And then subtract. When you subtract, you change the sign. X cubed minus x cubed goes away. 0x squared minus x squared is going to become a negative x squared. And then you bring down your next term. Our next term is our placeholder, plus 0x. So now let's see, what do we need to multiply x plus 1 by to get a negative x squared? Right, in this case, it's going to be a negative x. Right, when you distribute negative x to x plus 1, we're going to get a negative x squared minus x. All right, and now we can change the sign of everything, right, so that when we go to add it, negative x squared plus x squared is going to go away, and we get 0x plus x is just going to get us an x. And then bring down your next term. Your next term is a negative 1. And now you do the same thing. What do we need to multiply x plus 1 by to get an x minus 1? Or to get an x, right? We really just need to multiply by 1, right? It doesn't change the value at all, so let's just multiply by 1. 1 times x plus 1 is going to get us this x plus 1. And this cancels out, right? So let's subtract everything, change the sign of everything. And then x minus x goes away. And negative 1 minus 1 is going to be a negative 2. Right? And then our remainders, we're going to write plus remainder over divisor. Right? And that would be your answer. Right? So that's enough for this lesson. Right? The next section is going to be on synthetic division. Right? Some key things to take away in here, especially on this last slide, is to have little placeholders for any missing variables that are in standard form, or for any expression that's in standard form. This is always going to be the format for your answer, right? You have a quotient over here, a remainder up here, and a divisor down here, right? If you don't have a remainder, you're just going to see this portion, right? But if you do, then this is what your answer is going to look like every single time, right? So again, the process is going to be the same every time, and you can refer back to these examples if you need, right? Like I said in the beginning, right? It's going to get easier the more you practice it, all right?